In this section, we'll talk about how to solve polynomials. Remember that the degree tells us how many answers we are looking for. So finding the zeros means the same thing as solving. So let's look at this first example. It says find the zeros and label the zeros as rational, irrational, real, or complex. So finding the zeros means that we set the whole thing equal to 0. And then we split apart each piece and make each piece equal to 0. So we'll have x plus 3 equals 0, 2x minus 1 equal to 0, x plus the square root of 2 equals 0, x minus the square root of 2 equals 0, x plus, x minus 4 plus 5i equals 0, and x minus 4 minus 5i equals 0. So in each case, we need to get x by itself. So we'll subtract 3 from the first one, and that tells me that x equals negative 3 is one answer. The next one we'll add 1. That gives me 2x equals 1. And then we'll divide by 2. So x equals 1/2. From the next one, we'll subtract square root of 2. We get x equals negative square root of 2 is an answer. Here we'll add square root of 2. So we get x equals the positive square root of 2. Here I'm going to do two things at once. I'm going to add 4 to both sides. Here's my equal sign. But I'm also going to subtract 5i. And that's going to give my answer all at once. I get x equals 4 minus 5i. And that's my answer. I'm going to do the same thing with this next one. I'm going to add 4 to both sides. And then I'm going to add 5i to both sides. And that will give me my answer of x equals 4 plus 5i as my last answer. Now the directions also say label each zero as rational, irrational, real, complex. So let's talk about what those numbers mean, and let's start from the end. Let's start with complex. Complex zeros are zeros that have I in them, okay? So we can see right away that this answer is complex, and this answer is complex. So that's these two down here in purple. Okay, so if a zero is complex, let me circle that in purple so you can see it. It goes with the purple down here. If a zero is complex, it is not real. When we're breaking things down into types of numbers, we have real as one category and complex as another category. Okay, but real numbers can be broken down into different categories as well. They can be broken down into rational and irrational. Okay, so everything that's not complex is real. So that means this one's real, this one's real, this one's real, and this one's real. So rational numbers are numbers that are quote-unquote nice, okay? Basically, they're things that don't have messy square roots in them. So this one is rational, and this one is rational. Okay, so the first two are both real and rational. But the next two have square roots in them that don't turn out nicely. So if you try to do the square root of 2 in your calculator, it comes out as a great big long messy decimal. That's what makes it irrational. Ir means not. So this one is irrational. And this one is irrational. Okay, so again, rational, think of as nice answers. That can be fractions or short decimals, decimals that end, square roots that come out evenly. Irrational usually happens to do with messy square roots. So the rational zero theorem says that if we have a rational zero, it means that's a fraction, a number that's nice, then it has to be in a certain form. And this is our form, and we'll talk about that in the next problem. So all possible rational zeros, these are zeros that are nice, would happen in this form. We take this number at the end. Okay, and we take that 6 and we break it apart into all the factors. That could be 1 times 6 or 2 times 3. And we list those numbers on the top of our fraction, usually in number order. And then we look at the number that's at the beginning of the problem. So that in this case would be 1. And we break it apart into all its factors. And that just says 1, 1. So we're just going to list 1 on the bottom. And then we write that as all possible combinations. So we would put 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And then we want to simplify those. And when we simplify them, we want to list them as positive and negative. So we'd have 1 and negative 1. That's because 1 divided by 1 is 1. 2 divided by 1 is 2, so we'd have 2 and negative 2. 3 divided by 1 is 3, so we'd have 3 and negative 3. And 6 divided by 1 is 6, so we'd have 6 and negative 6. So these are possible rational zeros. That means that these are possible answers to this problem. They're not all answers, but they're all possible answers to this problem. So let's do that again. List all possible rational zeros. So we'll start with this one at the end. So we look at the negative 3, or just the 3 really. And the only thing that can break apart to multiply to get 3 is 1 and 3. So we'll list those numbers on top of our fraction. Then we look at the number that's in front, and that's 4. So we look at the different possibilities for 4. So that could be 1 times 4 and 2 times 2. So in the bottom of our fraction, we'll list 1, 2, and 4. We don't need to list a number more than once, even if it appears more than once. So now we'll look at all the possible combinations. So we could have 1 over 1, 3 over 1, and then we'll use this 2. So we'll have 1 over 2 and 3 over 2. And then we'll use the 4. We could have 1 over 4 and 3 over 4. So we'll simplify that now to get our complete list. 1 over 1 is just 1. So we'll have 1 and negative 1. 3 over 1 is 3. So we'll have 3 and negative 3. 1 over 2 is just 1 over 2, but we have to have positive and negative. 3 over 2 is just 3 over 2, but positive and negative. 1 over 4 is just 1 over 4, but positive and negative. And then 3 over 4, again, also doesn't simplify. So we just have positive and negative. So this is our list of possible rational answers to this original problem. Remember that degree of 5 tells you that there are 5 answers, and this is our list of possibilities. So now let's talk about how we use this. If we have problems, particularly ones we can't factor, then we have to follow these steps to find the answers. We're going to list the possible zeros. That's going to give us a place to start. Then we're going to look at a graph in our calculators to see which of that list you think might work. We'll use synthetic division to see if our guess, this is our guess here, to see if our guess actually does work. If we get a remainder of 0, then it does. If we don't, we need to guess something else. And then we're going to write our new problem. With that new problem, we'll complete those same 3 steps again and again until we get down to something that has a degree of 2 so that we can use a quadratic equation or factoring. So let's try that on a few problems. So step 1 is that I need to list the possible rational zeros. So I start with this end number, 6. And 6 can be 1 and 6 and 2 and 3. So that's what I want to list on top. The number in front is 1. So that can only be 1 times 1. So I'm going to list 1 on the bottom. So I'll start with 1 over 1, which is just 1. And negative 1, 2 over 1, which is just 2, or negative 2, 3 over 1, which is 3, or negative 3, and 6 over 1, which is 6, and negative 6. So those are my possibilities. So now I need to figure out, okay, so what of those possibilities do I think my answer is? So that's how we're going to use our calculators. So we're going to graph this in our calculators. To do that, we'll hit the y equals button. And then we're going to type this equation into that spot. So to do the x, we're going to use the button that looks like x, t, theta, n. When you hit that button, an x will pop up. So we're going to x, and then to the power of 3 plus 3, and then we have another x, so we'll use that x, t, theta, n button. And then you can do the power of 2, where you can use the button that looks like x squared, and that'll put the squared on it. Minus 2, and there's another x, so x, t, theta, n, and then minus 6. And then when you've got that typed in, then you're going to hit the button that says graph. So my graph looks something like, and all we really care about is if we're finding zeros, that means we're solving it. It also means we're finding x-intercepts. So on a graph, that's what we're looking for, is where it crosses the x-axis. So it looks like my graph does something like this. And all I have is these numbers to choose from. So I'd start checking. Does it look like it crosses at 1? Well, no, it doesn't look like it crosses there. How about negative 1? Nope, that would be right there. How about 2? No, it crosses between 1 and 2. So how about negative 2? Nope, crosses between negative 1 and negative 2. So then I try 3. Well, it doesn't look like it crosses at 3. That's out here. But negative 3 looks like it crosses right there at negative 3. So I think that maybe an answer would be x equals negative 3. So that's our next step. We're going to use synthetic division with negative 3 to see if that's really an answer. So we'll draw an upside down box. And then we're going to put this coefficients in the top row of the box. And we'll divide. Remember, we bring down that first number first. We multiply by the number outside, which gives me negative 3. And then I add inside, which is 0. 0 times the number out in front is 0. Add inside is -2. -2 times -3 is 6. Add there, I get 0. And that's my remainder. If this remainder is 0, then we have an answer. If not, then we have to try something different. It means that -3 never worked. But this one is 0, which means we have one answer. Remember, this degree of 3 tells us that we should have 3 answers. So we're going to use this to write a new problem. This tells me that now I should start with my x squared, because this was an x cubed right here. So I have to start one smaller. So I have x squared plus 0x minus 2 equals 0. And that's what I'm going to write on my next step. But I'm going to leave out this 0x because it doesn't really, 0 times x is 0, so we don't need to write it. So this step says, if the degree, check to see the degree. If the degree is 2, then we get to go on to step 5. If the degree is 3 or higher, then we have to go up and keep repeating. Well, here my degree is 2, so I get to go on to the next step. So here I have x squared minus 2 equals 0. So now I need to solve this x squared equation. So if I can factor it, I can do that, or I can use a quadratic formula. This problem doesn't actually have just a plain x in it, so I can use square roots. So I could add 2 to both sides. I get x squared equals 2. And then I could take the square root plus and minus of both sides to cancel out. And that gives me 2 answers. X equals the square root of 2, and x equals negative square root of 2. So there's 2 other answers. And remember, the answer I got earlier was -3. So there's my 3 answers. These didn't show up in my first list because they're not rational. They're irrational. They're numbers that don't come out nicely. So we have 1 rational answer and 2 irrational answers, but 3 answers total because the degree was 3. Okay, let's do another one. So in this problem, the first thing I'm going to look at was this piece, and that tells me that my degree is 3, which means I need 3 answers. Okay, so I have to work until I get 3 answers. So we'll start here with possible rational zeros. So I start with what multiplies together to get 2, and that's just 1 and 2. I put that on top. And then there's a 1 in front of here, so I just ask myself what multiplies together to get 1, and that's just 1 and 1. So I'll put 1 in the bottom. So I have 1 over 1 is 1, and I also list the negative. And then 2 over 1 is 2, and I also list the negative. So this time I just have 4 possibilities. So I'm going to look at my graph, and I'm not going to write it all out this time what we're typing in. You're just going to hit your x to the power of 3 minus 3x plus 2 into your calculator. And then we'll hit graph. And if I look at my graph, it looks like something like this. Okay, and to me it looks like it's crossing at this -2 spot. That's one of my numbers up here. Remember, I'm always looking for one of my numbers up here on my x-axis. So I think, well, maybe my answer, or one answer, is -2. So that's what I'm going to try next. So if I think it might be -2, I'm going to put that out here. And I'm going to draw my division box. Now be careful, because in this problem it starts with an x cubed, but there's no x squared. So I need to have x cubed plus 0x squared minus 3x plus 2. So I would put 1 0, negative 3, 2. So I start by bringing this first number straight down, and then 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Multiply outside. Negative 2 times negative 2 is positive 4. Add inside. That gives me 1. Multiply outside. Gives me negative 2. Add inside. Gives me 0. Because this is 0, I know that x equals negative 2 is one answer. So then I'm going to write this as my new problem. This was an x cubed up here, which means I have to start with 1 degree smaller here. So I'll have x squared minus 2x plus 1 equals 0. So I'm going to rewrite that on step 4. So here it is, and this tells me that if it's degree 2, I just need to keep going on to step 5. I don't have to do anything in step 4. So I'm going to write this in step 5, and I'm going to see how to solve that. So if I can, I want to factor, or if I can't factor, use a quadratic formula. Well, this factors as negative 1 and negative 1. So I set each of these equal to 0. And if I add 1, I get x equals 1. Here I'd add 1, and I get x equals 1. So I have an answer of x equals 1, x equals 1, and then my answer from earlier was x equals negative 2. 3 answers for this problem because it was degree 3. And notice that this answer is repeated. So we talked about earlier this chapter how that's a multiplicity of 2. It's an even multiplicity, and that's why we saw the graph touch at 1 and go back up. It didn't cross it, it touched it because this was repeated an even number of times. I'm going to stop there and start another video for the last few examples.